This video is an introductory video to airflow over a cylinder. In this experiment, a wind tunnel is used to cause airflow over a cylinder. This cylinder has on it a port or a hole that at this point is oriented against the flow of air. In the wind tunnel, the air actually flows into this section of the wind tunnel and then gets carried through to the other end. So in the test section right now, it's hard to see it on this video, but there's actually a port there on the side of the cylinder facing against the airflow. And then there's a tube attached that will measure, that's attached to a digital manometer that will give you the pressure across the cylinder in relation to the pressure, a pressure tap that is put on the side of the test section. In addition to that pressure measurement, there's also a pitot tube here. So those two are connected to a differential pressure transducer. There's two of them. Those replace the manual manometers. And so and that's all interfaces with a computer. At the same time, the cylinder is also you're also able to change the angle at which the hole is oriented in the cylinder. So if we were to go ahead and kind of focus in here, hopefully this will focus. So as you can see, there we go. You can loosen up these screws. As you loosen up these screws, you can actually change the orientation of the hole. So right now it's at 0 degrees, you can orient it as 10, 20, 30, and so forth. So all this interfaces with the computer. The computer is loaded with proprietary software that communicates with the data acquisition system that comes with the wind tunnel. So go ahead and click on the icon on the desktop called Tech Equipment VDAS. Right, as you double click it, it should open this window. This window has every single interface, a window that displays data that would be collected from every single interface available for the unit. What you're going to do is go through and make sure that only certain ones are checked. As you can see, I can check on or off certain interfaces. What you're going to do is make sure that DP cell 1 and 2 are checked. You're going to go over to make sure that manual angle input is checked, as well as atmospheric temperature, pressure, air density, and calculated wind speed. Make sure everything else, airfoil characteristics, are all checked off. The multi-channel pressure system, make sure that's checked off. When you open up the software, all of these will be checked. So you have to make sure to only keep the items that I just mentioned checked. Okay, at this point what you're going to do is turn on the wind tunnel. This turns on the power. You should hear the computer register the fact that the USB cable is attached. So right now, if you hear it, that means that the computer is ready to collect data. Press start. That turns on the wind tunnel. Now, that turns on the fan. Keep it at low for a moment. You're going to go over to the interface here and click on an icon on the upper left-hand side that says Initiate Communications with Device. That starts the system and allows you to monitor your data. Go down to Calculated Wind Speed. Make sure that first off, there should be a thermometer around here. Make sure you set the air temperature to the correct temperature of the room, because that will affect what the wind speed calculations come out as. And go ahead and turn this knob, which varies the wind speed. Turn that knob until the wind speed increases to a value of about 15 meters per second. I believe that's what the experiment handout has required you to do. So there you go, it's about 15 meters per second. Make sure that this is set to 0, manual angle is 0. Go over to the cylinder, make sure that's set to an angle of 0. And then go click on the pencil icon. The pencil icon just records data values. So click there. Go back to the cylinder. Set the next angle. Tighten the screws to clamp it down. Go over to the computer. Change your angle to 10 degrees. Click record data, and so forth and so on. Do that until you hit all the incremental angles as explained in the experiment handout. I'm going to go ahead and turn off the fan at this point. When you're done with collecting your data, go to this icon that says HTML. It'll export your recorded data to an HTML file. Save it to the desktop of the computer. Call it whatever you want. I'm going to call this test 4. Press save. And then up should come your experimental data. You can see here I have manual angle, 0 to 10 degrees, the output from the 2 digital pressure transducers, as well as my atmospheric temperature, pressure, density, and wind speed. Okay? And then you can go ahead and put that in Excel and then start processing the data. That concludes the instructional video for airflow over a cylinder.